this. So the setting up of the equations is going to be the same. The only difference is going to be the sign that we use, okay? So before we kind of do anything, there's not a whole ton of space. So maybe off to the side, I want you to think about a couple things in real life. So inequalities in real life would be, anybody been to Cedar Point? Probably a ton of you, right? So my kids are right at the age where they're not quite tall enough for some of the rides. They can get on like the Iron Dragon and a few other things. But when you go to each ride, it says you must be at least 48 inches to ride this ride. Or for some of the bigger ones, 52 inches. But the key word is at least. So I want you to think about the inequality signs that we use, okay? And think about which one of these symbols would mean at least. At least means the very lowest height you can be. You can be taller than that height, but you can't be less than that. So at least means, it sounds kind of weird, but at least actually means greater than, right? Because at the very minimum, you have to be as 48. Can you be 49? Yes. Can you be 50? Yes. Can you be 80? Sure. Can you be 47 inches? No, and 47 is less than, so it can't be less than, right? So it's kind of weird because at least makes you think less and you think less than. No. So kind of off to the side right here, I want you to just write a few keywords. So at least is going to mean a greater than or equal to. It means the very least height you can be, okay? So you can be 48 inches and still go on that ride. Okay, I want you to think about speed limit. I know you guys aren't driving yet, so speed limit, but you kind of have an idea of what that means, right? Okay, so the speed limit on Fort Street is 45 miles an hour. A limit means that's as fast as you can go, right? You can test the speed and see some cops get you for going 47 or 48, but the fastest you're allowed to go is 45. So which symbol would be for at most? So the opposite of at least is at most. So the most amount of speed you can go means that you have to, all of your other speeds needs to be less than it, right? So doesn't this symbol make sense for at most? Okay? So here's my advice to you on this. Don't memorize. Just use your common sense. Okay? If I say to you, or if you go to the mall and you have birthday money to spend, it's burning a hole in your pocket. You have $200 and you want to go to the mall and spend it. The most you can spend is $200, right? So which symbol would represent the amount of things you can purchase? It has to be less than or equal to that. If the most you can spend. You see where I'm going here? Okay? So if you're on a budget, those are the keywords that we're looking for. So you may want to grab a couple highlighters. I'm going to highlight some important information. So Emily wants to go to, she's in New Mexico, and she wants to buy some stones for her friends. They have large stones and small stones, but she only has $30 to spend. And she wants to get them for at least 4 of her friends. If she has enough money for more, then she's got 4 main friends that she really wants to give them to. So I'm going to highlight at least 4, and then I'm going to highlight no more than 30. Okay? That's the important information that I need to pull out first. And it starts out the same way. I'm going to set up a set of linear inequalities. So I'm going to say at least 4 of her friends. Does she want to buy them for maybe 5 or 6 or 7 friends? Yes. And those numbers are greater than or equal to 4, correct? She doesn't want them for 3 people. She needs to have at least enough for 4. Okay. But she can't spend more than $30. So which symbol would go next? Less than or equal to 30. Okay? Can she spend exactly 30? Yes, just not $30.01. Okay, she got to account for tax. So that's why that little line is there, because she can spend 30, but not a penny more. Okay, so you're kind of looking at, why did she just do the end parts? I kind of feel like it's important to identify the number of things you're talking about and then the dollar amounts you're talking about. Okay, so maybe we're just going to number of items, and then this is the dollar amount of those items. Okay, because people were kind of swapping these two around first hour. So keep your dollar amounts together, all right? So then she can get a total of, and I'm going to tell you that I would not use X's and Y's. I'm going to suggest that you stick with S for small and L for large. Did it seem to help you out in the last one? I think it really does. So the number of small stones plus the number of large stones, and when your variables look like letters, we use cursive. So that would look like a 5 and a 1, so we did it cursive. So do you agree with that? The number of small plus large needs to be greater than or equal to her 4 people, right? And then below it, all I go back up and do is how much for a small, how much for a large. And I have no question where to put it because instead of X and Y, it's S for small and L for large. It's $4 for a small stone, $6 for a large stone. Okay? And that is where you are done with these equations for right now because you know how you solved equations with elimination, right? You kind of just eliminated and you did it. We're not doing that. See this graph? We're going to use these solve by graphing. So what great review for your test. We got great elimination practice yesterday. We're going to get graphing practice today. The only practice you're going to really need is the substitution, right, for the unit test. So now, here we go. Write 2 possible solutions. I can't do that until I get something on this graph. So let's kind of get this on the graph. So what you may want to do is I always put the first one as your X and the second one is your Y, right? So I'm going to label this right here. So what is my X? Small. And my large is my Y. So I'm just going to label that real quick. So go ahead and do that. And then I need to get these on this graph, but it's not the form I want. So I need to do what with these 2 equations? Put them in, slope intercept, okay? Like when you are done with this problem, you're going to be like, we just did like 10 learning targets in one problem. Seriously, it's a lot. So I'm going to, this is the only reason that it would be tricky to, I didn't think about this, to put it in for, without it being X and Y, are you okay with that? Or would you rather switch them to X and Y for putting it in slope intercept form? You know, I didn't think about that. So you could just say X plus Y is greater than or equal to 4. Subtract X. Okay. This one is going to be Y is greater than or equal to negative X plus 4. Okay. Then I'd have to do the same thing for this. So I'm just going to make it 4X plus 6Y is less than or equal to 30. Minus 4x. Like these problems are going to take a little bit of time. There's a lot. Negative 4x plus 30. Divide by 6. If I divided by a negative, I would switch it, right? But I didn't, so we're good. This is going to give me a slope of negative 2/3 and a y-intercept of 5. If you could go ahead and do that, like I kind of feel like L is greater than or equal to negative S plus 4 would be kind of confusing for you. If you're able to go ahead and switch it to slope intercept without switching it, then good. But either way, just change it real quick. Okay, so now I have my 2 equations. I have Y is less than or equal to negative 2/3 X plus 6 or plus 5. And so now I'm going to plot them. All right. You may want to do it in your separate colors, or maybe what I'll do is just kind of highlight it here. So let's go to the plus 4. 1, 2, 3, 4. Down 1 over 1, just to be on the safe side. Just for right now, just use a straight edge or whatever. You don't need it to be perfect right now. For notes, we'll just keep going. Okay, I'm not going to shade yet. Okay? So I'm just going to kind of leave that there. And I'm going to say that this is my, I might just color code it with that, just to say that's that line. And then I'm going to plot this line, and that's going to be y. I'm going to start at 5. I'm going to go down 2 and over 3, down 2 and over 3, and then I'm going to do a solid line for that as well because it can be the line. And I might just kind of trace over it just to kind of, show that. Okay? And now I've got to figure out my shading. That is not supposed to be shaded on the inside yet. So now, according to the yellow line, what sign does the yellow line have? Greater. So I know it's not this little triangle. It's going to be above it, right? And then, where does the blue line have the shading? Luckily, I already shaded it. So it's below. So this area right in here is the only area that you need to have shaded. Let's talk about what that area means. 2 possible combinations means, okay, this girl wants to go buy some stones for her friends. She needs at least 4, but she can't spend more than 30. These are all the possible combinations that she can use and purchase and still meet her criteria. So this one is a little darker shaded in. So I'm going to use the first hour. So what I did was then I looked at inside the shaded area and I found 2 points. And I said, that looks like a point that would work because it's in the shaded area. And then the first thing I did was label that point. But what the heck does 4, 2 mean? Well, good thing I labeled my axes, right? It means that she can get 4 small stones and 2 large stones, which is why I wrote that there. Got it? Then I picked another point that was in that shaded region, and it was 2, 3. So she could also get 2, 3. So do you see how there's a bunch of combinations that would work? For equations yesterday, only one answer was right. Right? You had to have 19 of this and 11 of this. Well, you can have a bunch of different combinations, okay? So do you kind of see how this works? All right, what I also might do is this. I might say to you, here's a point. It's point 10, 8. Can she get 10 small and 8 large? And you have to look at your graph. You have to see if the point I just asked you about is in the shaded region. And if it is, you can say, yeah, she can get that. If it's not, you have to say, nope, not going to do it. She'll spend more than $30, or she won't get enough, or whatever. Okay? So do you kind of have the feel of that? So go ahead and write your 4 small, 2 large, or 2 small worked, and 3 large worked. Okay? Move on to number 2. All right. So let's figure out, you can spend no more than 15 hours a week babysitting. You need some money. You need to babysit. But you're also on a sport. You also go to school. So you can't spend like 80 hours a week working. So you can't spend more than 15 hours a week babysitting or working. Can you spend exactly 15 hours? Yes. You just can't spend more than it. And how much money do you need? Let's say your parents start making you pay for your phone or your text or whatever. So you need to earn at least $60. Okay? So right here, I'm going to write this one, and I need to write what no more than means. No more than means less than or equal to, correct? But I need at least, and that means greater than or equal to, right? So remember what I said about money stays with money? So people, like I said, were kind of flip-flopping these equations. So let's talk about the jobs. I can either mow or babysit. So I'm going to use, if you want, M came first, so that's going to be my X, babysit. So I'm going to use, if you want to use X and Y, you can. Okay, do you want me to do it with an X and a Y? Since we did it with a M and a B before, or maybe I'll do the next one. So mowing plus the number of hours that I spend babysitting have to be less than or equal to 15. Like, that equation has to make sense to you, does it? Take the number of hours that I mow, add it to the number of hours that I babysit, and when you add those 2 jobs together, it has to be less than or equal to 15. That has to make sense to you. And the reason I like the M and the B now is because, look, mowing pays 3, babysitting pays 5. If those are X's and Y's, I might be like, oh shoot, is it 3X or 3Y or 5X or 5Y, right? Do you see what I mean? It's an M. So it's $3 for every lawn they mow or for every hour, and 5 for babysitting. So there's like pluses and minuses of having it with the M's. And right now, I kind of wish they were X's and Y's, right? Because what do I have to do? I got to put it in slope-intercept form, but they're M's and B's. So guess what? That's up to you. You have to just decide if you can do it with the M and the B, or if you want to change it to X plus Y off to the side and do it that way. So this one is going to be Y is less than or equal to negative X plus 15. And go ahead and change this one. 3X plus 5Y is greater than or equal to 60. Minus 3X. 5Y is greater than or equal to negative 3X plus 60. So you go ahead and do this while I do this. This one I didn't divide by a negative. What do we got? 12. Okay, so I have two pretty workable equations. I may want to kind of keep them color-coded just to help you kind of figure your answers out. So now let's plot them. So this 15 is all the way up here. And I'm going down 1 over 1. Now, be careful because remember, some of you got burned on that last test by not making enough points and your line was a little off. So some people did this and like their line went this way, but it really should be exactly. So I'm just going to do a few more points just to make sure my ruler stays where it's supposed to and it's tilted in the right spot. Okay. I'm not going to shade yet. I'm going to graph my second line, but I'm going to make this one just so I kind of can tell later. And then this one is the plus 12, down 3 over 5. I'm going to do another one. Okay. I'm going to connect that. Okay, and again, I didn't shade yet. All right. So then, you know what I like to do? I like to highlight the sign in the color that I just highlighted the line in. So I know where my shading is going to go. So I'm looking at the yellow line, and I need to go where compared to the yellow line? Less than. And less than means below. So you know what? According to this yellow line, I know for sure the shading is either going to be that little triangle or this big area here, right? It's going to be one of those two, but let's look at the blue. Blue is greater than, so go to your blue line, and where is greater than? This way. So which section is it? That little itty bitty one, right? Were you able to come to that on your own or at least follow that for me? So let's shade that little section. Don't shade it too dark like I did on the first one. You're going to need to be able to read some points there. All right. This is a lot at once, isn't it? So are you at least kind of following me? So now I'm asking you, what are some different combinations of babysitting and lawn mowing that I can do and still make $60 a week and still not work for more than 15 hours? The only choices I have to do that are in that little area. So I'm just going to pick one or two that are pretty obvious. And then what is the X? Watch. Because look, I don't know what's on this axis right now. That's usually the X, right? So I'm going to put mowing here and babysitting here. So now when I have an ordered pair, I know that the first number is my lawn mowing and my second is the babysitting. So the name of this point is, that's 12, so this is 3, 11. This one is 2, 12. Okay, and so now I know that it's the mowing. So I could either do 3 hours of lawn mowing and 11 hours of babysitting. Or I could do 2 hours of mowing with 12 hours of babysitting. Okay? Does this make sense? Okay? I feel like you're good with these. Now, when I gave you the homework, there were some problems that were like technical thingies, like technical difficulties that people came across. Like somebody had to take this problem. Let me give you this right now, and let's do it together real quick so that you can see what I mean by this. Like their slope was like, they had to do up 1.5 and over 2.5. And they were like, what? How the heck do I show that on the graph? So I'm going to do one of these with you. Yeah. So let's look at number 1 real quick. And I just want to just show you a couple things. All right. So if you want to use X and Y, go ahead. All right, if that's better for you. So let's just look at our information. We're going to do flour and corn. You need at least 6 pounds, but you can't spend more than $25. Actually, guess what that says? You have to spend less than. So you must only have $24.99 in your wallet because you can't spend $25 because you have to spend less than it. I always just put the this one first. You need at least 6 pounds, but you have to spend less than $25. Don't draw a line under that this time, correct? Because you can't spend $25. So remember what I said? The number of things goes together and the money goes with the money. That 25 is money, right? So watch. The number of pounds of flour, which I'm going to make my X, plus the number of pounds of cornmeal needs to be at least 6 pounds. So I could do 5 and 3. I could do, because it has to be at least 6. So now watch. Flour is $1.50 a pound. Cornmeal is $2.50 a pound. Pretty helpful that it's an F and a C instead of an X and a Y right there. So I'm going to skip to something really quickly and just kind of show you one of the things you're going to be up against today. When I go to solve this equation for y, I have 1.5x plus 2.5y. Watch what happens. Minus 1.5x. So you have 2.50y. Oops, not that. Negative 1.5x plus 25. Watch. 2.5. 2.5. Okay? When you go to do this, you have your 1.5, because you know how usually it said 3/5? And you would be like, sweet, I just go down 3/5. Well, you can go down 1.5 and over 2.5, just like if they were whole numbers. But somebody said, I want to actually figure out what that is. And they found out that it's 0.6. So their slope is 0.6. Hey, I know that I'm teaching my 7th graders right now a unit on how to convert a decimal to a fraction. What fraction is 0.6? 60%. 3/5, right? Yes? So could you take this, and by the way, no, that's a positive. So this is less than. Could I change that 0.6 into that? Absolutely. All kinds of prior knowledge here. And then 25 divided by 2.5 is obviously 10. So now is that a little more manageable? Okay. There's also, I'm not going to do this one for you because I'm going to be done, but there's also another one. Holy cow. I'm talking $3,000. How am I going to fit $3,000 on this? And you know what? That's why they left the axes blank. Maybe you need to go by hundreds. Maybe you need to just put 1, 2, 3, 4, 5, but then just remember how we did that before where we said in thousands, right? So it's really 10, but doesn't it really mean 10,000? Okay, so you're going to have to get creative a little bit with how you graph these. So I'm going to be done talking right now so that